Hello and welcome. I'm Shashikant Chaudhary and I'm currently pursuing master's degree in AI and machine learning from University of Adelaide. So today I'm going to talk about large language model focusing on a technique known as LoRA or low rank adaptation. So what is large language model? Large language model are types of neural network that process and generate human-like text. These networks comprise of numerous layers that allow the model to learn from large amount of data. The most common architecture used in LLM is known as the transformer. The architecture is known for its ability to handle sequence of data, particularly useful in understanding the context within language. The model can be scaled up to billions of parameters, making them incredibly powerful for language understanding. Now let us understand what is fine-tuning and why we need fine-tuning. LLMs are initially trained on extensive and diverse datasets, which equip them with a broad understanding of natural language. However, the general intelligence isn't fully optimized for specific tasks. Fine-tuning is our tool to bridge this gap. By adjusting a pre-trained model, we can significantly boost its performance to specific tasks. To the problems of fine-tuning, firstly, these LLMs are trained on millions or billions of parameters, requiring powerful GPUs and memories. While it's super efficient, there is a catch known as catastrophic forgetting. This means the model can forget what it initially learned when it picks up new information, which is like overwriting old crucial data. Problems of fine-tuning can be solved using the technique known as PEFT or parameter efficient fine-tuning. It is designed to adapt large pre-trained models for different tasks efficiently by modifying only a few additional parameters instead of fine-tuning the entire model, which is often too expensive. One example of this is LoRA. Coming to the LoRA or low rank adaptation, it is a technique used to adapt large pre-trained language model. It was introduced by Edward Hu and his team in 2021. During 2022 and 23, LoRA has been integrated into Hugging Face PEFT library, enhancing its accessibility to developers, and studies have showcased its efficiency outperforming traditional fine-tuning methods. Coming to the working, the diagram shows the working of a transformer model. Initially, the input is tokenized and turned into embeddings, which are then passed through the encoder or decoder self-attention and feed-forward neural networks. These network weights are learned during pre-training and further adjusted during fine-tuning, where attention scores are derived and all parameters are modified. LoRA or low rank adaptation is a technique that minimizes the number of parameters that need to be adjusted during fine-tuning. It achieves this by freezing the initial model parameter in a place and incorporating a pair of low rank matrices with the original weights. We then keep the original weights of the LLM frozen and train the smaller matrice. This approach allows the original weights of the LLM to remain unchanged while only the smaller matrices are updated through training. For inference, the two low-rank matrices are multiplied together to create a matrix with the same dimension as the frozen weights. We then add this to the original weights and replace them in the model with these updated values. We now have a LoRA fine-tuned model that can carry out specific tasks. As you can see, we can fine-tune model for 3 different tasks and we can switch to any one of these during inference time as per our requirement. After running some experiment on FLAN T5 model, we can see that when we fed the input prompt into the raw model and if we compare its output with human baseline summary, it performs really bad. After fully fine-tuning the model, we can see that the model performs really well, but it needs lots of computing and resources. And underneath that is the output of PEFT model where LoRA is used, and we can see that its output is pretty much comparable with the fully fine-tuned model. These metrics shows the result of FLAN T5 language model fine-tuned for dialog summarization task. Evaluated using row scores. Initially, the baseline row score were below 0.25, which suggests poor summarization capability. After fine-tuning, the scores improved significantly, exceeding 0.4, indicating a good level of summarization. The fine-tuned model scores are similar to those achieved by LoRA fine-tuned model, making them competitive. Talking about its impact, it reduces the number of trainable parameters by up to 10,000 times, reducing computational cost. It also brings incredible versatility to AI application, allowing models to swiftly switch between. As we go deeper into the societal impact, LoRA not only minimizes the environmental footprint of AI, but also cuts down the cost associated with large-scale model training. Looking ahead, it paves the way for more sustainable practices and opens up possibility for broader applications of AI. Let's think about what LoRA means for the future of AI as we end this talk. It makes AI less expensive and easier to use, which could help more people benefit from it. But it also asks us to be careful about how we use it, to make sure it's fair and doesn't harm anyone. LoRa also starts new ways to explore how we can change models. Let us make sure we move forward carefully, making AI fair and helpful for everyone. Thank you.